Hello guys. So let's start solving some problems for today. Um, so let's go to the first problem we have for today. So as far as I remember, the problem I had for you. Let's start with the probability problem. Let me open the problem list for you. Okay, let's start with the probability problem. And so it's week 5 problem. So if you have problem list to yourself. Okay, it's asking the simple problem that if x1, x2, xn. So yeah, I'm sorry if the students who who have joined for the last 2 weeks, they will not get access to the problems. There's only students of the platinum batch and other batch will have the problems because it's hard for us to enroll everyone out there in the group. So if x1, x2, xn are random variables, as that. So the first thing you should do is writing down or marking the important ideas in the problems while you're doing the problem. So it's asking that x1, x2, xn are random variables. I'm writing down those, but you should be marking those because otherwise it will take some time during the exam. So are some random variables? It's not given IID or not. With mean is equal to 0 and with expectation of xi square is equal to 1. Okay. And also the relationship between them is given by expectation of xi xj is rho. So you can understand that variance is also equal to 1, and it also implies that it's also correlation between them is equal to xi xj is equal to covariance. So this is the information given. Okay, I not equal to j. The question is that there are 4 options on the question. Okay, the question says that number 1, rho equal to 0 if and only if xi's are independent. Number 2, variance of summation xi is equal to n if and only if xi's are independent. And other options are this, like the 3 options are this: variance of equal to n if and only if xi's are independent, if and only if xy's are pairwise independent, and if and only if rho is equal to 0. So understand option 4 options: x1, x2, xn are random variables with this given condition and relationship. It's asking about the rho and whether rho equal to 0 if xi are independent or not, and the property of the variance of summation is equal to. This is n means. So all of you understood the question? You have to write yes in the comment box. Great. Super. So now, great. So let's start understanding how to solve the problem first. So you can easily understand the first step you should understand is that this means equal to summation of variance of xi, right? Because each variance is equal to 1. Right. So this is asking whether variance of summation of xi equal to summation of variance of xi or not, and when it's true. So we already know that rho is equal to 0 if and only if when we can say from correlation that correlation 0 implies independent once if it's Gaussian. Okay, if it's Gaussian random variable. So this is true only if it's Gaussian, and there you should know that there are counter examples to that. During the exam, you don't have to form counter examples. It's not the subjective examination. So you know it's not true. Okay, it's not the other way around. So therefore, it's automatically getting cancelled. But when you're doing it in the, when you're doing these problems in home, make sure you write a counterexample down, okay, so that during the examination you can remember that there is a counterexample. Okay, so your homework should be to do a counterexample. Okay, at your home, if we get time towards the end, we will be doing counterexample or try to find one. We'll see how it works. Variance of summation xi is equal to n. Okay, but when if xi are independent, if xi are pairwise independent, when? So you have to make sure it's also other way around, the other way around also. Understand that. Great. Any ideas on how to approach this part? How to sum the summation variance of xi is equal to summation of variance of xi. So observe that variance of summation xi is equal to summation of variance of xi plus summation of I not equal to j covariance of xi xj. There'll be two ij pairs, so it will be twice covariance of xi xj, but I'm not writing that. I'm just writing this. So if these two are equal, then we are getting that these two are getting cancelled. So we have summation of I not equal to j covariance of xi xj is equal to 0. Now we know covariance of xi xj is equal to rho. So it's n choose twice n choose 2, because you can write it as twice of summation I less than j covariance of xi xj is equal to 0. So it's twice n choose 2, twice in n choose 2 covariance of xi xj. Sorry, covariance. So all of them are rho. Rho is equal to 0. Implies that rho is equal to 0. So this implies that rho is equal to 0. And if rho is equal to 0, you also know that it's like, you can see it's if and only if. Okay, both hand sides. So therefore, it's turning out that summation of covariance. So it's turning out to be that this is true if this is true. Okay. So the right answer is this. But what about this? This, like, are these not true? These are not true because it's the same thing. It's turning out that you can say that this is turning out to be the same thing. If we try to see that it's turning out the same thing if and only if rho is equal to 0. So therefore, it's turning out to say that rho is equal to 0 if and only if these two statements are same that we have proved here, right? This statement this statement and this statements are same, right? These two statements are same. We have proved that equivalent. So therefore, it's turning out that rho is equal to 0 if and only if xi is independent. So this is the new statement now, if you were to understand. And we know this is not true. We have just seen it above, right? Independence has nothing to do with covariance or correlation as such. So therefore, we can see that because if it's a multi MSQ, then you can see that it may be one of the options. So therefore, this is a thing. So do you want me to give an example where correlation is 0 but but it's not independent? Do you want me to give an example right now? Yes or no? So the problem is solved. You can see that. Yeah, it's an if and only if question. If and only if. All of them are if and only if question. Like options are if and only if. If you understood it, it's easy. It was easy problem. Do you want me to give an example, counter example to this part, that correlation is not 0 is equal to 0 if and only if xi is independent? It does not imply xi is independent. You want me to give an example?
So I want to second option, sir. Counter example for second option.
Second option.
Yes, sir.
All the options are equivalent to one counter example. Rho is equal to 0 does not imply xi are independent. That's the counter example. Like all of them has the same counter example. Rho is equal to 0 does not imply xi's are independent. I mean, xi comma xj, the correlation between xi and xj is equal to 0 does not imply xi and xj are independent. All of them has the same thing. You can understand that.
So xi is
So
independent means variance of summation of xi equal to summation of variance of xi now. That's what
I
my
didn't
doubt.
get your question.
Second option, sir. Variance of summation of xi equals to summation of variance of xi. When the xi's
Yeah.
are independent, no? Because xi's are independent means it will be a covariance will be zero.
No, it's asking like variance is equal to this, then which of them are true? Like if and only if. Okay. Now we know that this side is true. If xi is independent, it will imply this. But this side is not true. Like variance is equal to summation of variance of xi does not imply this are true. This two are true. It only implies rho is equal. That's what we proved here. Did you get it,
Okay, sir. I
Kangithara?
got it. Yes, sir. Thank you, sir.
All of you got it?
So can I ask
Okay,
something?
please go ahead.
Sir, as we had done in probability theory, in basic probability, that there are three kinds of independence of events. There's mutual independence, there's pairwise one. So does the same concept applies to random variables as well?
Yeah. So two
Where
random variables are independent if probability of xi belongs to a set a to a and times probability for all a comma b belonging to the corresponding blah blah blah. This is the definition of independence, like pairwise independence.
so when we
And
usually say that if they're independent, then it doesn't mean they're pairwise independent. So does that concept also apply?
no, that is not relevant here. That is not relevant here because
Because the options had clearly mentioned na, in B and C that Xi's are independent,
xi is
Xi
pairwise
isn't.
independent. So you can so this is true that if xi's are independent, if xi's are pairwise independent, then xi's may not be independent, right? If xi's are pairwise independent, then xi's are not independent, right? But do you think that if xi's are independent, xi's are may not be pairwise independent or must be pairwise independent? Because independence is a very strong criterion. What do you think?
I think if they're pairwise, then there's no reason that they won't be independent in general together. But the other way
Yes.
around, I don't think it would work.
So therefore, you should visit these concepts today. That counterexample. These are the things that you should learn today. Counterexample of covariance zero does not like example of does not imply that xi is independent to xj. Okay. Yeah, I'm going back to your counterexample. The second thing is that example of so the concepts of pairwise independence and group independence. Yes. Also revisit this question if x1, x2, x3 are independent. Okay. Does it imply that x1 comma x2 are independent? Like if we can say this, let's say I mean, does independence. So example of pairwise independence implies doesn't imply independence. And also proof or example of proof of independence implies proof or counter example pairwise independence. So you need to revisit all of this concept. That is what we have got from here. And also maybe you learn that um, correlation zero if and only if normal uh, independence for normal. So from this problem, you have got these ideas that you need to revisit, and maybe you can look at the proof and related concepts. So if you can't do it yourself, you can search it online. You will get online plenty of resources. But the ideas are very important. The questions, the things that you need to learn are very important. Okay, that's what my goal is here. That to make you understand that where you need to brush your knowledge up and what are the things you need to brush your knowledge up. So let's try to do this small idea problem. Like if x1, x2, x3 are independent. Okay, that means so independence implies pairwise independence. Okay, so so the basic idea of independence means that x1, x2 are independent if rather if you remember if x3 are independent, we have all the conditions. x1 independent of x2, x1 independent of x3, x2 independent of x3, and x1, x2, x2 are independent. All these three conditions are very important. Okay, that's very very important. So it implies pairwise independence, and in all all pairs, all triplets, all quadruplets, all combinations of xi should be independent. Okay, and what does a set of independent object means? It means that uh, product of like probability of xi belongs to a, xi x1 belongs to a, x2 belongs to b, and all these things will multiply in the probabilities. Okay, for all ab. So therefore independence implies pairwise independence. That's in the definition. Okay, so this is the definition. So this problem has nothing to do with that stuff because independence has nothing to do with correlation. So here all independent concepts are there. Independence, and independence has nothing to do with correlation in normal cases because we don't know the distribution of xi. Okay, so therefore we're not going into the depths. Like for solving the question in the exam, during the exam hall, it's not important. Okay, to go into the depths of all those things. Like you just have this concept that independence is not related to correlation. But when you're learning it right now, because the more you learn here, the less you have to think in the exam hall. Okay, more you learn here, the more in the memory of your brain, the less you have to process and do from scratch and prove yourself in the exam hall. That's why I'm focusing on these things so much. These are basic things that, oh, there's an example, so it's done, 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 done. So it will be fast. So that's it. All of you got it? And did you get it?
Yes, sir, it's clear.
Great. So just revise this concept out here. Okay, all this concept you can take a screenshot because probably I will not be able to share the notes with you. So take a screenshot of this if you want to, or maybe I can share. I'm not sure. Let's see. I mean, I will have to think how can I share. Um, okay, so the next problem. Problem 5 is done. Problem 6, probability. So it's interesting. Um, x1, x2, xn are IID. So IID you can write like this. Okay, this. So I'm teaching you shorter notation so that id some random variable, okay, with characteristic function. Why I'm teaching you this? Because you have to remember, don't have to remember characteristic functions, but you have to remember the moment generating functions, okay. And theta is equal to r to the power k. So there's a, they have a range of theta, like normal theta bar is means mu comma sigma square, that pair. Now z is defined as summation of xi, right? The question is that for which of the following distributions: negative binomial, geometric, hypergeometric, and discrete uniform. From which of the following distributions, like this one, for which of the following the phi of t, the phi of z, so this is, you can write like x, I, so the phi of z of phi of z just give me a minute. Okay, so phi of z of t comma alpha, so phi of z, like the characteristic function of z, will be of the format phi of z comma t comma alpha. So it will have the same format. What it's telling is that instead of this theta, it will be some alpha, but it will be of the same format. That's what it's telling. Okay, it will have the same format. Okay, that's what it's asking you to prove. So therefore, you have to remember all these characteristic functions. There's no other way. Okay, there's no other way. So it's telling you in some sense that when the format form will be similar, the expression form will be similar to xi, same as xi, just that the theta will be replaced by something else. SK, yeah?
We have to remember characteristic functions also along with MGFs.
No, 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 no. No. I just gave this problem so that you remember character. It's example to show that you need to remember the MGF. The problems, like instead of MGF, it can, instead of characteristic function MGF. Well, let's do it for MGF, okay?
I guess
So
it is about additive property of.
yeah, it is
Uh,
about additive property, but you
so
have to
which
remember the format. Like you have to understand that of course, you can find out the phi of z. The phi of z will be nothing but you can understand phi of xi whole to the power n. Did you get that, guys? All of you got that? Do you have to explain why this is true? All of you got this? That why this is true? Yeah. Anyone who don't know this?
Son, I don't know, son.
Okay. So phi of z is expectation of e to the power it or just xi or z. Z is nothing but summation of xi, so you can just write it down as e to the power it x1 and you multiply it all out because xi are independent, right? And multiplication, so it's whole to the power. These are nothing but phi of xi and all are IID, so therefore it will be same. So therefore we get this. Okay, so therefore phi of z is equal to phi of xi whole to the power n. So therefore understand it will be of a similar format if it's of the format like phi of xi, if it's of the format some a to the power t, a to the power t something, or like a to the power beta t, then phi of xi whole to the power n will be of the format a to the power beta nt. So this beta will be transformed. You understand? So therefore, this gives an idea that if it's of the exponential format, then probably it will be, of the similar class, similar format. So therefore, the beta is transformed to beta n. That's what is asked here, okay? And beta was probably a wave function of theta. Okay, so that is what is asked here in this problem. So do you remember any of the characteristic function, or you can just replace with mgf? It does not matter. You can replace with mgf or mgf. So go to the mgf list of yours and check. I have to also go because I don't remember. Of course, I'm not giving the IIT JAM. So yeah. So we have negative binomial, geometric. So for negative binomial, it is of the format, weird format, p minus 1 by to the power t plus p to e to the power t whole to the power n whole to the power r. Geometric, you can understand it will be r equal to 1. It's similar. I mean, there are some, some aspects out there. Yes. Binomial is, sorry. So you just check out, okay? Just check out all the list and get back to me. It's your work right now. While I'm writing it down. Hypergeometric, I'm not getting the hypergeometric one. And discrete uniform is discrete uniform is not something interesting. Hypergeometric, you have to check. I personally think it will be this negative binomial, because you can see that if you do whole to the power n, it becomes this, which is nothing but the negative binomial Rn comma. Okay. So essentially what this means is, this fun part is this. Essentially what this means is that it will be the same format. This will be the same format if and only if. Can someone tell me? Can someone tell me if and only if? Yeah.
Yeah, if the distribution has additive property.
Very good. Is the distribution additive property. That means
We don't
that
have
if summation xi is follows in the same class of z, it falls in the same class of z. So now a negative binomial, then only it will be happening. Okay, that's the basic idea. So this is that where the problem is becomes beautiful. Okay. So it will be in the same class if and only if summation xi follows the same as xi, like in the same distribution format. So it's additive, as SK has told. So it's additive. So therefore, you can only see that negative binomial is additive here, because summation of negative binomial is negative binomial again. Also, there could have been gamma. If summation of gamma could have been gamma again. So just the continuous version of negative binomial. Okay, we have made a video on that. This was a beautiful problem. This was a very conceptual problem. Okay. So all of you understood this, yes or no? Similarly, instead of giving this, they can give some different thing. Let's say product of log or something, summation of log. Okay. So remember these things in mind when it will be following in the same class. So remember this idea. This is a very beautiful idea. All of you understood this, yes or no? It's a beautiful problem. Yes, okay.
I have a doubt regarding since characteristic function came up, I have doubt regarding Cauchy. So, absolute fractional moments of Cauchy exist,
Yeah,
but usual moments don't exist.
yeah.
And what? So, is there a proof for that? That is one thing. And second, what can we say about folded Cauchy?
You don't have to remember all this. It's extra. A lot of knowledge you don't need to remember for IIT JAM. Regarding the existence of Cauchy, it's product of X to the power R. You can just it's nothing but indefinite integration. So you have to do it like when the integration exists or not. Those things. Okay, that's it.
Okay.
You can actually prove it by, as far as I remember, I did it. You can prove it by uh, sandwich theorem and then using the what it's called comparison test. You can prove it by comparison test. Yeah.
Okay. Okay. One more thing about Cauchy only. Um, the scaling and shifting property of Cauchy, that scaling thing should be positive only, right? The scaling factor should be positive only, right? Or not?
I forgot the definition of scaling and shifting. I think it's positive. Yeah. Because if it becomes negative, or no, Cauchy is actually um, even, right?
Huh, yeah, it is symmetric.
So therefore, I don't think there is negative or positive issue to it.
Okay.
I mean, if alpha x belongs to Cauchy, then minus alpha x also belongs to Cauchy because
Huh, okay. Okay.
all of you
Uh,
understood this. Whatever we have learned right now, this is a very important problem. It's also true if it's not characteristic function but MGF. I only see 3 answers. That's why I'm getting back to you. No, yes, maybe. Okay, great. Others, didn't you understand? If not, please tell me. I will explain it to you. No worries. Okay. Uh, okay, great. Thank you for sharing. Let's go to the next problem. Okay, this one is interesting. This one is easy too. This one is also a very common thing. This is about the distribution of IID continuous and symmetric ideas. So here you revisit concepts of MGF, IID property. I don't have to remember the MGF, but maybe you have to remember MGF formula. There are takeaways from here. There are takeaways from here. Now let's go to the next problem. So x1, x2, xn are IID some continuous distribution. I have to find probability x1 greater than x2 greater than x5. Yeah. What is this? What is this probability? This is nothing but the basic aspects of symmetric distribution, symmetricity of random variables that we have taught in our classes. Yeah. So how do you do that, Aniket? Great. Super. SK Aniket. Yeah, I know you remember. Super. So how do you do this basic thing? It's very simple. It's very simple. It's um, x1. So it's symmetric random variable. Observe that x1 are IID. So therefore, this probability are if you replace x2 by this, and let's say x3 greater than x4 greater than x5, and let's say x5 greater than x3 greater than x4, the probabilities are same. Why? Because These are IID, okay? Does not matter the order. These are all IID, okay? So the order does not matter. So XI is same behavior, X1, X. These are all same behaving, okay? So if you just rename it, it's the same thing, same probability. It's a renaming of the whole thing, right? Because they're IID and continuous. Now, continuous is not mattering, but continuous will not matter now. But IID, this is happening due to IID, the equality. So therefore, you can see that probability, any permutation, tau I is a permutation. Is same as this. I mean, are all same, are so all same. Let's equal to lambda, right? Are all same. The permutations are all same because of the same IID property. Now observe the probability if any xi is equal to tau, like understand that this is, if you sum over all this tau, sum over all tau, all the permutations, tau is a permutation, okay? Is a permutation of 1, 2, 3, 4, 5. And tau t is where t goes. So over all permutations, it must be equal to 1. Why? Because this is the only possibility. We know since it's continuous, let's say probability x1 greater than x2 equal to x3 greater than x4 greater than x5. This is always 0 because this is this because it's a continuous distribution, and hence this equality case will enforce the 0 in one dimension. Okay, it will become a lesser dimension thing. So therefore, the probability will always 0. So therefore, all the other nuances, the other aspects, okay, of the existence of of the entire sample space like this, these are all 0. So therefore, it's saying that this is the only possibility because in every single case there will be one maximum. There's an order. Okay, there's order of the numbers. The probability of two numbers will be equal is 0. So therefore, there will be always with probability 1, there will always be an order in the numbers, okay, in the random variable. So there, because again I'm saying it, probability of two numbers being equal is 0 because the IID continuous. So therefore, this is now we are taking the all possible orders, okay. Since we are taking the all possible permutations, so it's equal to 1. This is happening due to continuity, continuous distribution. So this is the important step, and this is the important step. Now, if you add it up, the number of permutations is 120. So 5 factorial times lambda, this is lambda, is equal to 1. So therefore, lambda is equal to 1 by 5 factorial. So all of you understood this? This is the solution, yes. All of you understood this? Yeah, Shukrit?
So I mean, I have a doubt about similar problems because this is a kind of like combinatorics problem.
Mm-hmm.
So in the 2022 paper, I saw a dearrangement problem. Okay.
Okay.
So which can also be done like it says the 5 men go to a restaurant together and each of them order a dish that is different from the dishes ordered by the other person. However, the waiter serves those randomly. So what is the probability that exactly one of the dish he ordered was correct? I mean, he uh, the waiter serves the dishes randomly, so only one of them will be correct, will be given to the correct person. Okay.
Yeah.
So I mean, I tried it first like a binomial problem. Now the answer I got and using the dearrangement, though those two answers are different, like by 0.2
See,
thing.
I understood why you took binomial because I also did the same mistake when I did it initially. The binomial thing, understand that remember the summation of the independence. Check the binomial conditions. Okay, it's not actually binomial. Okay.
Okay. Acha, that's
The
why
independence aspect and IID aspects. Check that binomial aspect. They're not independent. You will say it's not independent the way you are doing.
Okay. So
Just
we
check that
have,
aspect.
I mean, the error was very less, but it's out of the bound from the answer key given. So that's why I asking that. Okay, okay. So we need to do that from the de-arrangement formula, right?
Yes, there is no other way.
Okay.
The binomial thing, you may have told it correctly, but it's related to something called, you can also do the de-alignment by using something called PIE, principle of inclusion exclusion.
Yeah, yeah. But so that's the I mean the derivation comes from.
Yeah, but I think PIE is related to somehow related to binomial. Okay, so maybe you can just check that idea.
Okay, okay.
Okay, so also I forgot, SK gave an answer to um, the normal thing, IID and stuff. Just check it out, in that message of her answer, the counter example, that when it's correlated or something like that. X follows standard normal, Y follows x square, covariance of x is equal to, yeah. Just check it out, okay? Yeah, yeah. So what she gave an example, it's interesting. I will just write it down here. X follows normal 0 1. Let's say y is equal to x square, so covariance of xy will be equal to nothing but, you can understand, expectation of x equals 0, so it will be nothing but expectation of x cube. Now any order moment of normal is 0, but you can see that y and x are not independent, they are related. Thank you for the example. Yeah.
So,
Yes.
so I wanted to ask something in this symmetricity problem.
Sure.
More or less, whenever we are given such problems, the coefficients of these random variables are unity. But suppose if we have x1 and x2 and the only two random variables in question, and it is given to calculate x1 probability of x1 strictly greater than k times x2. So I tried to use all the combinations, but for
No,
exponential,
their combination will not be, so this will be so the IIT thing will not be there. So it's k times xi. So you have to do it. You have to compute it using law of real probability. You have to condition next to, okay, and then you have to do the law. When it's like of the format probability x1 greater than k times x2, you do the law of real probability. So it's integration whatever the range is, x1 greater than kx small x2 into f of x2 comma x2. That's the only way out.
so it's not working because these are no longer IITs.
Or yeah, or you can just find x1 by x2 if let's say some, so you can just find 1 minus CDF of, yeah. So both the ideas, both the things are important, IID and x1. These are important. Now the thing is that the IID thing will be, the independent thing will be happy useful here. Okay, that's it. But if you say some, if like for example x1 by x2 may have some good properties, okay, may have a distribution, good distribution, so you may use that idea here if you know that. Yeah, all these things are important, like IID and one second. Sorry, IID and continuous both are important. Did you get it, Ian?
Yes, sir, clear.
Yeah. Okay. All of you got it? Yes or no? SK, you have a doubt? Please go ahead.
Yeah, I have a doubt regarding what Shukrit asked about the de-arrangement problem. So why we can't use the binomial? Is it because probability for what each success will be different, because it will be dependent on in what combination the other people get dishes.
Yeah.
So that's why it is not binomial, right? Like for
Yeah.
each time it will like for each person it will be different thing.
I mean, the hat of one can go to any of the other person, okay? And given the hat of one goes to two, the hat of three, like the ordering is different.
There are
Every time.
possibilities. Like for each thing, the number of possibilities become different. Like if we fix one, like we say that let's say hat one doesn't go to person one, then let's say there are only four people, and if we fix hat two goes to two, and sorry, hat two goes to three, sorry, third person, and the remaining two will go to the other two places. So if the number goes on increasing, the number of combination go on. Sorry, the number of possible permutations go on increasing, and they're different. Like
Yes.
each time the probability is not same, so there we can't use the binomial thing.
So the
It's
probability is same, but they're not IID. They are not independent. The probability will be same because uh, because the number of people remaining are different, same. Oh no, wait. The probabilities will be different. Yes. See,
how
if
probability
x3,
is different, na? That
yeah,
this is where we're
because let's
confused.
say x1 ka hat goes to x2, okay. Yeah, the probabilities will different, and they're not IID. Like it's independent, it's dependent, and they're non-identical. Just check it out, like basic things. Yeah, I mean the idea is correct. What you have told, yes.
So the thing, it violates in binomial ka assumptions.
Just give me a minute. For one, the first step, the IID thing, like it's IID. For the next step, it's not IID. So whatever Shukrit got is like the PIE ka principle of inclusion exclusion ka first part. So the rest of the minus plus, that part is getting cancelled out. Like it's very slow probability. So therefore, the answer is coming similar to Shukrit's one.
Okay.
Yeah, please go ahead. You're asking me something.
Yeah, no, I got it.
Okay.
I was just confused about which assumption it is violating exactly.
You just check it out. Like you can just think about like take for n equal to 2, 3, 5 small numbers and check it out where it's violating. Okay, all of you understood this problem, guys? The last problem, symmetric problem. This is very important, and you should reply to me in the comment box. That's the only way we are interacting. Okay. Okay, so the next thing is that what if they're not IID, like xi follows exponential rate I from this will not be satisfied. So we cannot compute like that. Okay. If xi doesn't follow if xi are not IID, so yeah, if xi are not IID, you have to do it like this. Yes.
Like find the joint distribution and then integrate.
No. If xi are IID independent, then I mean
Independent, not ID, but independent.
so this not joint distribution, but yeah, you can just use law of rule probability. Okay, it'll be easier, quicker. I mean, we will come to this part only if you use joint distribution, but this will be faster, nothing else. Yeah. Law of rule probability is very useful. Okay, great.
Is it like convolution thing that probability, like integral
No,
for
just
probability?
use this condition on x2 is equal to x, and then multiply this. Now x1, x2 are independent, so it just depends on x1, and just like do simple stuff.
Okay.
Just practice more, you will get it. Don't worry. Okay, the next problem. Probability. So the 30 questions in a MCQ. Each question paper has 4 options. This question has 4 options. One to be marked. It's MCQ. Okay, just one to be marked, and 3 candidates A, B, C. So the first step is you make a visualization of the problem. Okay, that's it. Just it's recapitulating the problem. Okay, that's it's just preparing for before. I don't know how many of you cook, but if you cook, what you do is that you arrange all the ingredients. Okay, before starting to cook, so that it's easier and you can put it any single time. Similar like that, you're arranging the ingredients and the concepts out here so that you can map it out and play with it. So 3 candidates ABC mark each of the 30 questions at randomly, independently. At random, independently. Okay. Probability that all 30 answers match is perfectly is what? That's interesting. So therefore, yeah, how do you model this scenario? How do you model this? What are the random variables A, B, C? Can someone tell me? They are doing it randomly. Yeah. Because probability of x2 is equal to x3 is equal to 0, because for continuous distribution, x2 for two continuous distribution x2 and x3, x2 minus x3 is equal to 0. So x2 minus x is a continuous distribution. So probability of continuous distribution taking one single value is 0 from the third. That's all. Okay, coming back to this, so also trying to ask the questions, maybe you have some network issues, plus if you're online, try to ask the questions when the question I'm asking you to ask your doubt. Otherwise, when we're discussing a new problem, it is difficult for people and me to go back and forth. Okay, so A answers 30 questions, B answers 30 questions, C answers 30 questions randomly. Okay, and how do you model this? So therefore, AI is and BI and CI are the answers of the ith question by A, B, C respectively. Okay. So can someone tell me what AI, BI, CI are? Discrete uniform. Very good, Vanshika. Discrete uniform. Let's say 1, 2, 3, 4. Right? Discrete uniform 1, 2, 3, 4. Exactly. And BI also discrete uniform 1, 2, 3, 4. And CI also discrete uniform 1, 2, 3, 4. So therefore, AI, BI, CI are nothing but IID, discrete uniform, DU 1, 2, 3, 4. Okay. Great. So therefore, the probability AI is equal to BI is equal to CI is nothing but what? Is equal to sum of probability AI is equal to BI is equal to CI is equal to, let's say, one of the options. They're doing it randomly. Let's say I from 1 to 4. So therefore, summation of I, PI AI equal to I, that's J, sorry, J, probability PI is equal to J, probability CI is equal to J. So each of the ordinals is 1 by 4, so it's 4 times 1 by 4 cube. It's 1 by 4 square, 16. Right? So their IID, therefore it's getting out and they're equal value. Okay? They are getting multiplied. So therefore the probability that one answer one problem ka answer is same is this. Therefore the problem, all of the problems ka answer is same is what?
One by 60 to the 30th part.
Yes. So all of them are done independently. So it's essentially probability, if all of them are same, is nothing but probability 1 is same. 4 to the power 30 questions are there, right? So it's 4 to the power minus 2, 4 to the power minus 60. All of you got it? Now, why this is 4 to the minus 60? Because all questions are answered independently. That's it. Got it?
Could you please explain it again?
Which part?
Full questions.
Okay, you couldn't listen?
No, sir, I didn't get. That's all.
Okay, which part you didn't get? Can you explain it to me? Like, which part? I cannot, you understand.
Why we are
For example,
AI, BI, CI?
huh?
Why we are taking AI, BI, CI?
Okay.
4 options are there.
So AI is AI is the answer of the ith question by ABC respectively, by A rather. So it's people are selecting the options randomly. So therefore AI is discrete uniform 1, 2, 3, 4. That's it. I mean, it's randomly equally likely. So it's discrete uniform 1, 2, 3, 4. It's taking either option 1, option 2, option 3, option 4 with equally probability. So therefore it's discrete uniform 1, 2, 3, 4. Did you get it?
Yes, sir.
So therefore AI, BI, CI all same distribution, right? And they're independent. So therefore I wrote this and I calculated this like probability A equal to CI, AI equal to BI equal to CI. Now we're using this is called law of real probability again. We are possibilities of them equal to, what are the possibilities? J, 4 possibilities equal to J. So we are summing it up. J from 1 to 4. That same option, which option? So either option 1, option 2, option 3, option 4. And now this probability is nothing but probability I equal to J and probability BI equal to J and probability CI equal to J. And we are distributing all this, dividing all of this because they're IID. And all of them are 1 by 4, so it's 1 by 4 cube, and sum is over 4 objects, so 1 by 4 cube into 4, so 1 by 4 square. And all of them are same, is like 30 options. So probability first is same into probability second is same because all the questions are answered independently. And therefore it's 4 to the power minus 2 or to the power 30, which is 4 to the power minus 60. Okay, got it?
Yes, sir.